What up, what up, what up, what up, what up? What do I want to put on today? Let's just do some synthwave. This is a stream just for me. So it's random. I'm not supposed to be streaming today. It's not on the schedule, but I want to do it. Something's been bothering me. I haven't eaten, so I probably won't be on here too long. Gotta do a little bit of that social media marketing real quick because people don't know that I'm on. What is it, milk? What the hell? I don't know. What does that say? Milk cakes? I don't know. Okay. Twitch. Let me open up my manager here. Doing this super last minute, on the fly, off the cuff. What's bothering me is this analysis I just read. So I'm actually going to take a second to go over Coordicide. By the way, it's an interesting name considering it kills their coordinators. So I read the NIRS evaluation of it, and that raised so many red flags that I'm just like thinking I have to go through the paper itself just to make sure they didn't understand it or interpret it wrong or nothing's changed. Last update's January 2020, so I'm assuming it hasn't changed much since the article. But then the article's at June 2019. So I don't know for certain. I have to double check. That's why I'm kind of just going to take a second and look at what's going on here. See if I can actually figure out why these IOTA guys are trying to claim that they didn't just straight up implement Avalanche. Oops, let's see, twitter.com. Yeah, I should tell some people, huh? Don't want to get too far into it. Give people a chance to kind of show up if they want to. Oops, don't want to open that window. Hey, what's up, Slim? So I went over I'm bored. I guess it's better to have a boring life than stress. And so I decided to go over that pillow sucks, I swear. I need it because it keeps my neck from like snapping back. It keeps falling down. Anyway, I went over the avalanche analysis by Mr. Skidnov. And there were just some fundamental misunderstandings here about just S in general, stuff in general. And it's so fundamentally flawed that I thought there's no way they're doing it. So I'm going to go over the actual IOTA paper too. This article's quite old, mind you, but like there's something just fundamentally screwy about what he wrote, like bonkers, that I have to be like, let's take another look at this. Let's go deeper. Let's see what's actually going on here, what they're actually planning. And again, this article is from June 5th, 2019. But this actual paper directly from their site, I just clicked on, literally. White paper download, boom. This is from January 2020. So what I'm going to do is just compare this to this and make sure this doesn't have the same fundamental misunderstandings about consensus in general that this does. And I'm not even an expert, mind you, guys. I am not an expert in this. Like, I just picked up a lot while I was working at Ava Labs from experts, and it made it easier for me to spot things like this, some conceptual stuff that I think a lot of people miss when they're designing these things. And so I'm trying to make sure, do a little sanity check here. So first off, might as well just hop into it really quick. Okay. Just to get us started. There is no debate they're implementing Snowball. Nobody is debating that. Not Mr. Skidnov. There's no question there's extreme similarities from anybody I've seen. They are implementing Snowball. Without question. Okay, so long story short is you have a network of N nodes. You select K samples of those N nodes for a certain number of rounds until you reach a certain confidence, okay? And these guys got this idea that they are going to improve termination, is how he puts it. Now, I just read this article. I haven't gone over their paper at all. Okay? They're going to improve termination. Which, by the way, if he's getting the terrible results he's getting from in his terminations, let's just outline what he's got here. So he's got consensus properties listed here. You got agreement failure when two nodes both decide that some outcome was agreed upon, but the outcomes differ. Okay, I get what he's going at there. He didn't list anything about integrity failure, I don't think, if I recall. But that says when consensus is reached on some outcome, but that outcome was not proposed by anyone. Okay, fine, it's an identity thing, I guess. Yeah, I think just say random data just gets injected somehow, whatever, I don't know. That's nonsense. Anyway, I mean, it's true it can happen, but like, that's like it's not even really what I would consider a consensus problem typically if stuff like that is happening. It's an identity sort of like issue. Like, you're accepting data that you should, I don't even know what to call it. You're expecting data. Nobody should be agreeing on data that's not from an entity that didn't like propose it, right? So, and I don't know what that's about. Then you got this termination failure, okay? When no consensus is reached after an arbitrarily long period of time. All right, so first off, something you need to know about consensus. There's 3 really big kind of like types of synchrony bounds you got. It's like purely synchronous. There's various flavors of that. You can have an actual clock, which goes with actual time. Or you can be like Bitcoin, where you're synchronous, everybody's coordinating, but around these like blocks. So there's a certain difficulty, which kind of like synchronously gets everybody in lockstep on the network, right? But it's synchronous, you know? Block after block after block, but it's done instead of like as needed, and it's like literally in lockstep. Everybody does the same thing. Everybody like boom, boom. Okay, it's like boom. Okay, so some sort of like clock-like mechanism, and on that tick, a new piece of data gets proposed or written, right? And then there's asynchronous protocols, which like basically, as transactions come in, or as vertices, or as whatever comes in, blocks even come in, they're agreed upon on demand. Right? With purely asynchronous though, which is kind of not a practical category to be honest with you. It could take from 0 to n time, meaning it could go on forever with no upper bound. That's the definition of pure asynchrony, okay? It can literally go on forever. It's valid. From a consensus standpoint, it is a valid way to do things. You can say, I'm going to do this. I'm going to wait forever to come to a decision on this. There's nothing wrong with that. There's no inherent need for termination in consensus at all. Okay? So that's fine. If there's a termination failure, as he puts it, in practical sense, yeah, it would suck, but it has nothing to do with like the consensus properties in and of themselves. In fact, you can do that with Avalanche. It can be totally asynchronous if you need it to be, but it's not practical to do so. So we added things called like timeouts, which I wrote the first iteration of, and then Steven definitely had to redo because my code was not great for that, I'm not going to lie. So I mean, it got us through the next phase, but like, yeah, it needed redoing. Termination failure is not a failure. It just means a decision never was made. That's not a problem. If nobody comes to any decision, that's fine. Like, from a theoretical standpoint, purely theoretical, okay? It's not a breaking thing for consensus. It's not ideal in any way, shape, or form in a real world scenario to have no termination on any decision making. None. Like, it's kind of bonkers. It would suck. So what people do is implement timeouts. And when you start doing stuff like that, you get into the partially asynchronous category. And when things are partially asynchronous, you know, for the most part, things can come in at any time, but there's some sort of like upper bound on how long it takes for decision making to be done. So that could either be a hard limit, like all decisions must be made in under 5 seconds. You can get as many transactions that could come in as needed at any point, right? You can literally just come on in, but they must decide in 5 seconds. Like that's a valid partially asynchronous rule, right? Another way to do it, which is close to what we do, is that you can kind of like bump that margin up. Like, oh yeah, I mean you get 2 seconds or 3 seconds to come to a decision, but you know, if you're doing work and everybody's still like returning stuff and you're getting different results, you can bump your personal timeouts like a lot. And that's the other thing about partial asynchrony is it can kind of like be a more personal decision-making process. So, like, yeah, it's valid by the. I just want to point out like this termination failure, point number 2, which he's picking on here, is nonsense. I mean, from a practical sense, I understand why somebody who is only building practical stuff would look at it and go, "This was a failure," but it's like, yeah, like. But it's solved in other ways. Like, you don't have to do it. And, like, there's no such thing as like whatever. The other thing I want to point out is, according to Alexander's like work, it took him forever to come to consensus on some stuff with only 4% of Byzantine nodes. And I am sorry, but homie, you did something wrong. Like, really wrong. We can show that right now, by the fact that our network is running and you can just throw conflicting transactions at it, it will come to consensus and you can deploy 4% Byzantine nodes if you really want. You can build a local network right now. Just use Avash, which is a tool that I don't think is, I don't know, it's good for internal, it's good for stuff like this, I guess. It never turned into what I wanted it to turn into. That's fine. S happens. But you can launch Avash right now and launch a local network and simulate this yourself. You can even do network deployments with it. It'll and then do your own tests. Like, you can do that right now. I guarantee you will not have the horrible results. Where is it? The horrible results you're claiming to get. Our simulation showed, but we saw that with parameters private, consensus can be kept in a metastable state for thousands of iterations. Pardon me, but no. It converges. Yeah, we are, because it's nice to show how much of an expert the Ava Labs team are. That's why I want to do this. Like, the more I do this, the more it shows to at least people who are watching me that the Ava Labs team are top notch in their field, like unquestionably. And if you're investing in people who aren't Ava Labs and they're claiming, "Oh, we're not Avalanche, we're not completely copying what you're doing," and Ava Labs is going, "Yes, you are," or "What you're doing doesn't make sense because of XYZ," you should probably consider Ava Labs an expert at this point. And if you don't, I want to show you why they are. Okay? And if that makes, like, I know it's hostile. I don't even care. Like, I don't care if it's hostile. Like, I'm tired. Yeah. Like, why are we constantly defending ourselves against people who have not even 1% of the qualifications of the top team at Ava Labs? Right? I'm not even up to them, right? I'm not even up to their level. Not even remotely. Like, but I, just by working with them for 15 months, got enough information into my head that I can look at this stuff and go, this sucks. Right? I built their JavaScript. I built the consensus. I built the transaction builder in TypeScript. I worked on the timeouts. I did the RPC calls. I did the very, very earliest iteration of Ortelius. I got to name it. I committed us to Kafka and that kind of thing. But like then it was Tyler and then it's Todd. Like I did that work. I built Avash. You know, I chipped in where I could. I helped manage some of the stuff. That's what I did. I am not a consensus protocol expert. I helped build the platform. That's what I did, okay? But in the process of that, I worked with Ted Yin, I worked with Kevin Sekniki, I worked with Stephen Butoff, and I worked with Dr. Goon Sirer, right? And I picked up enough about this along the way that I can spot that this is junk. Why are you giving these people your money? I'm very aggro about this. I don't care, okay? I'm a fortunate person. I got nothing to lose. I'm basically just a single guy living in his apartment alone. I can lose everything. I don't care. I just want this to stop. So I'm gonna go over this. There's no way in God's green earth they implemented the snowball correctly. There's no way. You can test it right now with our implementation. You can run our own simulators. You can run Ted Yitt's simulator in JavaScript if you want. I don't care. Like, figure out a way. Like, you've not we have somebody in chat right now, no text editor, who has done his own simulation work. He is not seeing the same thing you're seeing. With 4% of the nodes adversarial, you will not go through thousands of iterations. Sorry, no. Anyway. Hi, Sangren. How's it going? So, like, look. That alone just, like, set me off. Like, you did something wrong. Don't blame us. Well, let's go back to actually the problem here. They're talking about termination. IOTA couldn't develop a secure wallet, got hacked. Rolled their own crypto, failed over 10 days. Still have a coordinator after 5 years. Changed their white paper twice. Lost 2 out of 4 of their co-founders. If that isn't enough to know about the project, good luck to you. That's right. And so I don't think Goon should share the stage with people like these. I don't. I think Ted should share the stage with people like these. And it's frustrating to me that there's nothing in this space to measure quality against because it's such a difficult space to break into and understand. And so, like, I'm not trashing the fact that they did work. I'm trashing the fact that they are not correct when they make the statements that they make. They are copying Snowball, okay? And then they add this thing on top and say, oh, they've been saying that they're not a copy of Snowball and that, you know, they're something completely different. And they have to say that. So does Flare. They have to say that. Now that the patent has been like shown, like somebody found it. Now that they know that the patent application is out there and that it's likely to pass, it looks like it's likely to pass, they have to differentiate. They are going to try. They're going to try, or else they're going to lose all their work. But like this is not going to pass. They're not going to pass. Like this will be shot down immediately. It will not be very difficult for an actual gosh darn expert to come in and look at this and go, nah, you're using exactly what's in the patent already. So all they were doing right now is they're saying, like, according to this old article, I want to mind you, old article, still plan on looking at the paper after this. I don't know how good I'll be at it. I'm not a consensus protocol expert, okay? Like, I'm a guy who learned stuff for 15 months and came out better than when I went in, okay? But I'm not Kevin Seknicki. I'm not that guy, right? I know because Kevin Seknicki taught me, and only the things that he taught me I know, okay? Which, granted, biases me, but they're tautologically true. You cannot, like, fake that stuff. Like, that is legitimate, like, this is something that is absolutely, you could just take them as axioms of truth because we've proven that through academic research years before Nakamoto ever came out, right? Well, some of it's after. But, like, the point is that we know what the bounds are on things. We know what works and what doesn't work already. And then when somebody proposes something and say, I've invented something new and it doesn't work, well, you have to put it in the category of like, no, we already know what the second law of thermodynamics is kind of thing. Like, we know that perpetual motion machines don't work kind of thing, right? Like, you don't address that in a serious manner. The burden of proof is so tremendous when you try and violate these laws. You have to show something that differentiates yourself from these other protocols. Now, classical protocols had that issue where it was like, okay, you're hard cap upper bound at 33% in a Byzantine network on asynchronous protocols. We can't get better than that. So if we came along and said, yeah, we're going up to 60, even 80% safety threshold, you know, anybody who thinks we're a classical protocol will be like, no, dog, that won't happen. But there's a differentiator there. Classical protocols are P equals 1. They're probability 1, okay? Probability 1 protocols. That means they... Thank you, Nicholas. They always come to consensus. I'll also post this in there as well. They always come to consensus with 100% certainty that all nodes, as long as the assumptions hold true, all nodes will be safe. They will be completely copied over, right? But we're not P equals 1. We're like Bitcoin. Avalanche is probabilistic. So when you do that P equals 1 minus little epsilon, little tiny error bit, like the chance of a hash collision is acceptable. When you get to that point, you know, you've got a whole different paradigm to work with. So that's what differentiates Avalanche from, say, classical protocols, right? So you can say that Avalanche goes over because there's a whole new area of research at that point, right? But when you're using literally Avalanche, and then you say that you're fixing some of this, like, all right, you know, I'm off topic. I'm ranting like a lunatic. I love doing that. That's okay by me. Let's go back on topic, right? They're saying, this paper says that they're going to fix, this article says, this blog from June 2019 says, termination failure. When no consensus is reached. By the way, this got cited to me online. That's what they're doing. They're going back and they're using this stuff. Oh, look, the NEAR guys agreed with us in 2019 to, like, argue with us. Nobody's serious about this. Anyway, just go back, just show you what they got wrong. Termination failure, when no consensus is reached after an arbitrary, blah, 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 blah. Okay, so they said, okay, everything is exactly the same. Literally, this is what the guy says. Like, everything is exactly the same, but they changed the termination. Okay, termination's not part of consensus. I just spelled that out. Like, it's not, you could terminate in any multitude of ways, but like timeouts, they're a perfectly valid way of doing termination if you really want. You know, so That's whatever, but they said they added this thing. They added a random beacon. First off, I'm not really sure what that random beacon is. I'm hoping it's in the paper. Like, are they using like a threshold relay like Definity did, which is probably also patented? Wouldn't be surprised. Or are they using like a beacon, like a random kind of situation? See, consenting on a random number is actually a hard problem, okay? That itself is like a consensus problem. If everybody in the network has to come to agreement on one number, that is literally a consensus problem. So a random beacon is not something that's trivially achieved. So I want to know what methodology they use for that random beacon. But let's just assume that the random beacon is reasonable and valid, and there's no question that the randomness exists, okay? Again, hard problem, don't know how they're doing it. Randall would be a solution, but again, you need consensus to agree on what the next Randall number will be. Sort of, I guess. Yeah, you do. So, you know, whatever that randomness beacon is, I mean, maybe BLS ring signatures, just like threshold relay does, which I have to read up on again because I don't remember the details on that right now. Had a really great interview with Manoush, who moved on to Facebook from Definity about that, and it really cleared things up for me. I don't even know what Flare's doing. I only got enough energy for IOTA today. I will do another one with Flare. I promise. Okay? I will. I promise. Just follow me, subscribe. I guarantee you I'll do another one of these with Flare. I just only got enough energy. This is like literally an impromptu thing too. I'm doing this for fun. Like, and if I don't feel like doing Flare today. I don't want to shoot you down, but like I'm doing this just for me. This is my own self-gratification. But if you, like, I guarantee, I will do Flare. I know it'll come up, and I know, like, soon. So just follow me. I'll do it. All right, so, I like, literally Flare copied our client, but they just, like, changed the Sybil mechanism to something they claim is novel, but, like, I hate to tell you, the Sybil mechanism is not remotely related to the consensus protocol, and so just by changing the Sybil mechanism, you still violate the patent. Big time. Because the consensus protocol doesn't dictate a Sybil protection mechanism. An article I'm planning on writing, I was actually going to do it today, but this kind of caught my attention instead, is basically an outline of Sybil. Like, what the hell is Sybil? Like, why? Like, because it's a constant struggle to have something to point to and go, this is what Sybil actually is. Like, for really technical people, like, they still conflate proof of work with consensus. Proof of work is not consensus. Proof of work is Sybil protection. I call them Sybil mechanisms. Proof of work is a Sybil mechanism. It is a way of a rule set for for preventing a bunch of pseudonymous people from creating fake accounts and manipulating the voting power on a network. You want to restrict all the agents to have one set of voting power, and the way you do that, typically in a decentralized network, is to associate a cost with it. In a centralized network, you use something like a certificate authority because it's much cheaper, easier, and faster. Proof of work is just adding cost. So, like, just adding Sybil protection, is not changing the consensus rules. I'm sorry. And not even on a fundamental level. Just what we're protecting, what Avalabs is, or I'm sorry, I should say Cornell. What Cornell has protected is the concept of using random statistical sampling to show that the network can come to an agreement. That's the consensus. You do that, better get a license. So, anyway, so what they're saying is that each node does its current sampling thing, okay? What he's saying here, I'm assuming because he didn't mention rounds, that he's also considering rounds here. Then after the rounds, the nodes do some distributed randomness generation to generate a threshold between blah, 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 blah. Okay, assuming they do that. Okay, assuming that is the thing that they're doing, then each node chooses 1 if the number of nodes prefers 1 in their sample was bigger than beta times k, otherwise it chooses 0. Okay, fine, so it's got this little binary check there, right? But the problem with this approach is it does nothing for the network. You've gained nothing from this. You've gained nothing. So what they're trying to do is assume a forced termination through a random beacon. And people select the random beacon. They all agree on this randomness. If you don't have the right random number, you were trying to do something malicious, basically, right? Okay. The problem is it's doing this so that an adversary who has perfect knowledge of the network, meaning that it knows the state on every other node, can't manipulate the network. Which is exactly what Avalanche proves you don't need. First off, you don't know the state of the whole network. If you did, you wouldn't need consensus to begin with. You would just go, I know what the state of the network is already. I'm going to go with the majority of that, right? Nobody can know the state of the whole network. That's the point. And it's an ad hoc network. People are coming and going as you please. So that attack vector is effing moot. There's no reason to do anything to protect against that nonsense attack vector, okay? Second off, like, I don't really see how any of this solves anything, considering that the entire proof of the Avalanche paper was you don't need to worry about the whole network having, like, a swayed, like, adversarial, like, participant. Because you don't know which direction the network will go to, you know? And because you can't have perfect view of the network. It's kind of the point. It's like you just know that the network's going to come to a decision, and you're just going to go with that decision. That's all consensus is anyway. Like, you don't know what the network is, so you're going to all agree based off the same process to come to an agreement. That is the basis of decisions, right? Like in Bitcoin, you don't know what somebody's going to sneak it, put into a block, right? You just know that they published a block and you recognize it as valid, and therefore you're going to accept it. It's got all transactions signed for with valid, valid signatures, blah, blah, blah. It's like, yeah, okay, these are the transactions that go in this block because the leader, who is the person who mined the nonce, put it in there. They're fighting non-existent problems. They're hunting unicorns that don't exist. Like, there's nothing wrong with number one. There's nothing wrong here. Like, assuming they have the rounds thing, which they left out of that. Assuming that they're just using Snowball and Snowflake, there's nothing wrong past that point. It's exactly what it needs to be. It's exactly what it does. So why are they adding 2 and 3? Because they're trying to make boogeymen. So if you're not familiar with consensus protocols, it's easy to believe 2 and 3. I even almost made that mistake on my stream when somebody was asking about 51 and 49%. It's like, no, actually none of that matters, right? The network will come to an agreement. That agreement will be valid. All the transactions will get through that are valid. Conflicting transactions will not get through. That's what you're trying to prevent, right? So, and then there were, like, especially in a partially ordered versus totally ordered network, like, I could see some MEV stuff maybe on a totally ordered network, right? It's difficult to pull off at these speeds, but I think it's still possible. But in a partially ordered network, like, it's, who cares? Like, signed the transaction, we agree that this is the transaction that was signed. You are the person posting that transaction. You signed it. Nobody can sign for you. If there's a conflicting transaction, you sign the same UTXO twice. Like, why'd you do that, dog? We're just gonna pick one now. Like, that's what it boils down to. And totally ordered networks may be different. Like, you could say, oh, I'm going to put this transaction in before that one to game the books or something, or, yeah, fine, get it. That might be an issue. But in a partially ordered system, like, pretty much, I mean, I'm sure there's still some stuff there, but, like, whatever. Every transaction gets in as it gets in, right? You can do maybe in vertices or something, The same transaction should not conflict inside of a vertice either. So yeah, I mean, like, literally this whole system, this whole thing they're proposing, the solution, as he has said, is freaking nonsense past one. You don't need to do this at all. It is already fine right here. They're manufacturing boogeymen so that they could neg, pickup artist term. I'm not a pickup artist, but I love the term. They can neg Avalanche. And basically anybody who's looking at Avalanche will go, oh, well, the near guys. Who are the near guys? Like, I mean, I know everybody in this space is smart, right? Everybody in this space is smart. Don't get me wrong. I'm based, chill, bro. I'm based. And I am pretty red-pilled. Anyway, like, I'm black-pilled. Burn it all down. Go full Joker. But, no, like, anybody in this space is smart, but they're smart. Like, I would have fallen for this 2 years ago, okay? Like, it's reasonable to fall for this. That's why they do it. But I don't think it's even intentional. I believe they don't know better themselves. That's where I'm at right now. I believe, even though they're manufacturing boogeymen, they're looking for boogeymen and they're seeing them, even when they're not there. Because it's in their best interest to do so. I don't believe this was malicious. I don't. I believe that Mr. Skidinov, Alex, I'm going to call him Alex. I believe Alex was not being malicious. I don't see any reason why he would be malicious. It's not like this is actually something that I could see somebody accidentally thinking. No question. So, you know, that's the problem we're facing here. Is like legitimacy is virtually impossible to suss out in this space, right? You don't know who real experts are and what they look like. And everybody sounds like an expert when you're not one. I spent almost 2 years on my podcast trying to talk to as many people as possible to figure out who the best experts were, right? And the first time I heard Goon, I didn't believe him. Because I didn't know who he was. I'm gonna be frank with you guys. I'm not a star. I don't get starstruck very well. Like, I don't like look to figure out who's who. I'm just not that guy. Somebody could be very popular, I wouldn't know. Like, unless they're like really popular, I'm not. Goon's getting to that stage, but like back then, no. He was big, but he's like 30,000 Twitter followers, or maybe 60 or 70,000 Twitter followers big. Now he's getting bigger now. This is a thing. I didn't know who he was. I'm not gonna lie. The first time I talked to him, October 2018, didn't know who he was. And you know what's even funnier? I might have communicated with him in 2012 about another project called Hyperdex when I was working for another company, because I thought Hyperdex was amazing. And I didn't even remember his name. I'm pretty sure I might have emailed him about that one. Because I liked Hyperdex. Hyperdex was brilliant. It's a really good project. Really cool. Really cool way to do things. I don't even remember the details on that either, though. I just know that I loved it. That's all. So I remember I got really into it for like 3 months and then forgot about it. Nobody used it. Grad student dropped out. Not of the grad school, but like dropped off the project or something like that. So that's a shame. But Hyperdex was an amazing project, and I think I might have emailed Goon at one point. I would not be surprised. Would be very surprised if I did not email Goon to find out what the status was with Hyperdex like a few months after. So, but I didn't know who Goon was still. I didn't. I knew what Hyperdex was, and so when I read his background, I was like, whoa, that's cool. Like, how do you determine who an expert is, right? I will say the weirdest thing to you guys. I didn't know that Cornell was a good school. I'm serious, dead ass. Did not know. I asked that my first day at Alva Labs, and people thought I was effing with them. I did not know that they were Ivy League. I had no idea, because I'm so far detached from all of that. And these people, some of them are in it. A lot of the people reading this, though, some of them are out of it. Like, I asked what's an Ivy League, because I didn't know what made a school an Ivy League school. I just knew that they were supposedly good. I didn't know, because I'm not that guy. Like, I never was into that stuff. So, like, I hear Cornell, and it's on the same level as, like, Virginia Tech in my mind. Like, that's Georgia Tech, like, all that. Like, no, yeah, it's probably a good school. I don't know, is it? Maybe. I never really heard of it. Where's Ithaca? Like, I am the target audience for this article. That's the problem. You need to realize, like, I am the target audience, or I was, I guess, maybe I'm not anymore. I was the target audience for this article, okay? I know that people fall for this crap. I have 3 huge articles on my Medium about plasma that I am totally ashamed of. Because I had bought all of it. I believed plasma was going to change the world. I read that white paper. I was like, this is super dope. I started interviewing people on my podcast after that. I started getting more information, and I was talking to the people trying to implement this stuff and build it, and it became clear to me very quickly that people will just write whatever they want. They just write they just write any idea that comes to their head and hope that it works so that they could be like, I'm the person who invented that. It's unprincipled. It doesn't come from a place of first principles. And first principles annoy the hell out of me. I do prefer values to principles in some respects. But at the same time, you don't make as much progress with values as you do principles. You can actually measure a principle, the results of a principle better. Like, yeah. These people are not coming from a place of like structured thinking. That's probably the better phrase for it than principles. Structured thinking. It doesn't even matter if you can change. Maybe you could change a principle. I don't think you're intended to when people talk, but like if you're not open, then maybe openness should be a principle. Open to change your principles should be a principle, you know? But like, I think it's the lack of structured thinking, structured thought process that some people have and some people don't have. So anyway, I looked at this and I went, oh my God, like this is all you need. Why are they doing this trash here? What is this nonsense? What are you doing? Like, what is this? What is this randomness? You don't have a perfect view of the network. What node, what adversary has a perfect view of the network? How are you going to do that? That's not how this works. You can't, you're designing against the most imaginary. What? And even if they had a perfect view of the network, you aren't guaranteed. You're still guaranteed to come to a good consensus decision. You can't implement a Byzantine decision past 1, assuming that 1 also includes the rounds, which they don't have here. It does sound like it should, but they didn't write it there. You cannot come to a bit like you cannot do it like you can't come to an. You need to violate safety to screw that up, and that means you need over 60% of the 80% technically all the way up to there, like 60, 80, 40, doesn't matter. You need to have over the threshold of staking authority to actually violate safety. So what are you coding against? These guys have more money than me. Stop giving people your money. I keep talking about funding and how it's a blight to this ecosystem. Stop giving these people your money. I shouldn't say that out loud. I just... Do what you want, invest in who you believe in, invest in the marketing, invest in whatever you want. But don't invest in things that you don't understand and expect them to always work out. You can, I mean, like... Yeah, I can do that. I can do that. Am I being loud, Moonboy9001? Is that what's going on here? Look, I'm not going to go... I guess I could go deep in this. I love how they have a glossary for... and it's like... got some of those basic stuff in there. Like, do I really want to go over every little damn detail of this? Where is the... Can I jump to the part they're talking about specifically? Because if that is still in there, then all I can summarily throw out... All I need to do is validate they're using Avalanche and then show this and summarily throw out this paper entirely. So they talk about the current IOTA implementation, DAG, Tangle, blah, blah, blah. New research challenges. By the way, just so you know what I'm doing, I'm verifying that this is in the paper. And I don't know what to look for, so I'm just kind of like slowly scanning down. I know what I can look for. Random. Bleh. Tip selection, blah, blah, blah. I'm just trying to verify that what Alex wrote in his paper is still in Coordicide. Whoa, we just jumped all the way to 4.2 from like 2.1 by searching on the word random. Hey, what's up, Tyler? You're missing a hell of a rant. Tricking other nodes into becoming neighbors. Neighbors established when one node sends a peering request message to another node, which turns into... Okay. This is... This test determined request was indeed... Okay, look. Select chosen neighbors, sort by distance, blah, blah, blah. I don't know what they're doing here. So what is the category of 4? Auto peering. Okay, this is not something I need to worry about. Scrolling down more. Rate control, adaptive POW, theoretical, simulation. I should search. This is not going to work. Consensus. There. Oh, yeah, they got a table of contents. I should have just done that. Fast probabilistic consensus, FPC. Let's see how they do this. Introduces a protocol, low communication complexity, blah, blah, blah. FPC's relies on the idea to randomized voting, i.e. random queries, is in some situations sufficient for good performance. Okay, it's already starting to sound like snowball. Another advantage is randomness is robust, less reliant networks and situations. Yeah, okay. Mentioned also classical work on probabilistic Byzantine consensus, blah, blah, blah. In order to analyze the security of FPC, we must find assumptions about the behaviors of the participants in the system. An honest participant is one that assumes blah, 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 blah. We assume that Byzantine attacker is we assume that a Byzantine attacker is omniscient? It is aware of every current opinion in every other node and observes all communications? They are saying that. That's dumb. I can't believe that. Here's a participant. An honest participant is one that we assume to follow the system's protocol for rules as specified. A Byzantine, active or malicious participant, is one we make no assumptions about, since the participant behaves arbitrarily fast without any restriction. Since this is the strongest adversarial model, we want to focus primarily on Byzantine attacks. We further assume that the Byzantine attacker is omniscient. Okay, well, that's fine. I guess, I mean, like, look, if you know every other node on the network, what they look like, you don't need a consensus protocol at that point. But if you're trying to F with the whole network, because somehow you know the worst case, which is like you know everything. I get that. Okay, I get it. If you know the worst case, you know everything. You know the whole attacker. Yeah, I get it. I get it now. Okay. I get it. Okay. So you know the whole network is bad. Can you F with that network? To what degree can you F with that network? Got it. Okay, fine. So let me look at this with this in mind, okay? So you know that the whole network is what the whole network looks like for some reason. You know what the entire network looks like. How does this gain you anything with termination still? You're still going to terminate you're not terminating any faster or slower. Okay. That's my bad, guys. I want to go back. See, this is a problem. Even I'm not an expert, but I look at this and I go, okay, there's no way that somebody's an omniscient attacker, whatever. But I get why they do that now. Okay. So they're going to assume that the hacker is omniscient and can F with the network. somebody knows exactly what to do and when to make this a problem. Okay, first off, they need to have the staking voting power to do it. They say above it only takes 4% of the nodes to be adversarial to cause thousands. Each could. Where is it? 4%. Oh, it's probably above. We show the parameters in that paper to consensus be kept in a meta-stable state for thousands of iterations, with just 4% of the nodes are adversarial. I mean, that is not correct, I believe. So, but that is a worst case scenario. Like, somebody knows the entire state of every node on the network. Let's just say they work their code in, they can into the client, and they can sniff on that. Okay, fine. All right. Further assume the Byzantine attackers on blah 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 blah. The adversary's Russia may delay sending its own messages any given round until after the honest parties send their messages in that round. Okay. So they are faster than everybody else and can get their stuff in first. That's fine. We have to assume the assumptions of the communication model. We assume the communication between two nodes satisfy authentication, the senders and receivers, blah, 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 blah. We assume that omniscient adversaries do not assume confidentiality. Probabilistic synchronous model, blah, blah, blah. Participants being Byzantine. In practice, we not make security assumptions that over half or 2/3 of assumptions are honest. We have to make the security thresholds that, okay, so over half or over 2/3 of the participants are honest. Okay. Which is it? Why would they? Those are two very different statements, but okay. Maybe I'll figure it out in a sec. The distinguishing feature of this mechanism described in blah is that larger numbers of adversarial is allowed, maybe fixed proportion of the number of nodes. These adversarial nodes are tending to either delay consensus or break it, so they're just trying to screw with the network. It shows that nevertheless the protocol works with a high probability when its parameters are suitably chosen and some explicit message, blah 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 blah. Differently from the classical work in this area, it's not required that consensus should be achieved with high probability on the initial majority. Rather, if initially no significant majority of nodes prefer 1, the final consensus will be on the value 0 with high probability. If initially a supermajority of nodes prefer 1, the final consensus will be 1 with a higher probability. Yeah, okay. To explain why this is relevant, blah blah blah. Legitimate transaction, buy some goods. Okay. Special feature of the protocol is that makers of the sequence of random numbers, which are either provided by the trusted source or generated by random nodes themselves, use some decentralized random number generating protocol, providing that the not too large by leveraging cryptographic primitives such as secret sharing, blah blah blah. More specifically, a reasonable approach could be used a variant of DRAND protocol. I don't know what that is. Already used by other projects such as the League of Entropy. DRAND? DRAND? What is that? Oh, here it is. Oops, don't do that. Okay. There we go. What's DRAND? Distributed randomness beaconing. Okay, cool. So, I'm not sure. Collectively by DRAND nodes and publicly available, the main challenge in generating good randomness is that no party involved in the random generation process. So it's probably, like I said before, yep, okay. Yep, BLS. I mentioned that earlier. Yeah, so this is similar to threshold relay. That's reasonable. Although I wonder... Yeah, that's reasonable. So, yep. It's basically threshold relay, ring signature groups kind of stuff with BLS. Blah, 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 blah. Okay, cool. important to observe that even if from time to time the adversary can get total or partial control of the random number, it can only lead to delayed consensus, but he cannot convince different honest nodes different things. Safety is not violated. Yeah, because it's using Avalanche. So if you stay under the assumption, then we present here some key elements proposed for blah blah blah. In order to find FPC, we have to first introduce some notation. First, we assume the network will have n nodes, and every node has an opinion on state. Cool. Nodes have a... Okay. Each discrete time step... Each node chooses k random nodes, queries their opinions, and calculates... math. So add a discrete time step plus 1 is equal to the times the ith k of the time, the current time. So the current preference, I guess. Yeah, query of the current preference, I guess. So for each node, and then, hi guy, I'm new to the space. I've been interested in Avalanche recently. Would you recommend reading the paper even without knowing a lot about blockchain tech, or should I start by reading about the tech first? Definitely start by reading the tech first. You know, if you don't know, like, I don't know how new to the space you are, but I would actually start with just like this. Yeah, just start with this. It's pretty good start. You could also go to docs.avox.network. I am so terrified that one of these autocompletes are going to show something like pornographic. Yeah, I said that out loud. All right. You also check that out. It's a good place to start. Okay, so back to this. So you've got K, T, so okay, and then the sum of, yeah, gross. So you got K, T is the time variable at some discrete time point, the opinion of I at T, of a sample at T, and then the sum of, what is S? Chooses K random nodes, CI, oof, there we go. So CI, and you guys are probably like, oh, it's off the screen now. I wonder if I do this, will it help? Bollocks. That helps a little, huh? Okay. So J and CI, is that an S or? Yeah, that's an S for sure. Where's S? Did they define that somewhere? So it's supposed to be something I already know? Boo. Alright, well, I think I can skip that for a second and come back. So where ki is greater than k, okay, less than or equal to k, is the number of replies received by the node I at the time t, and there we go, right there. S of t is equal to 0. Okay. If a reply from j is not received in due time. Okay. But the neighbors ci of a node I are chosen using sampling with replacement, hence repetitions are possible. So I see. Are they calling neighbors the rounds? Yeah, it's more like, yeah, basically. Yeah, I say I shouldn't have said that because I don't know what I can and cannot say. I don't know what counts is like you have to prove damages, I think, if I do something like libelous. What's the word? Not libel. Yeah. Slanderous? Slanderous is verbal, right? Libel's written. I have to be careful. Like, I just don't want to be like, I'm trying to explore something here. I want to give myself a wide enough berth to not, like, say something stupid and get myself in trouble. You know? Alright, so note that the neighbor's CI of the node I are chosen using sampling with replacement, and hence repetitions are possible. I'm guessing... So they got a nearest neighbor thing going on there to select the nodes that they're actually sampling. Consider basic version of FPC introduced in choosing some parameters by default. Specifically remove the cooling phase of FPC and the randomness of the initial threshold. Some parameter B, such a B as in this is between 0 and 1.5. The update rules and the opinion of the node is given by if n of 1 is greater than the initial threshold, otherwise 0. And for t, n of t plus, so this is the initial state, and then once you start getting into it, it goes, and so this is multiple rounds. Alright. That looks to me. Choose some parameters by default. Specifically, remove the cooling phase of SPC. What is... Hey, Tyler, are you there? What is, I mean, you're welcome to come on the stream, by the way, if you want to go through this with me. But what is the randomness of the initial threshold? Is that tau? What is that? Yeah, it's tau. Hard to see. Remove the cooling phase of the FPC and the randomness initial. What the hell are they doing here? Say choose random nodes, get their opinions, calculate this. That is looking a lot like... Yeah, I'm trying to figure out if this randomness that they're talking about is already introduced. Yeah, I don't know what the hell that is either. Randomness of the initial threshold tau. Like, what the hell are they doing? This looks similar, kinda, to Avalanche, to Snowball, kinda. Like, these are the rounds, I guess. Kinda. I don't know. This is really hard to grok. Is it because I'm dumb, or is it just built that? Is it just written that way? Yeah, that's basically what I'm trying to think. Like Romile, Romala. Yeah, what are they doing here? Like, am I stupid, or is this stupid, or is this like? Or am I smart and just not smart enough? You know what I mean? Like, what are they... What is... Just local termination. Max iterations. Halt! Halt after max iterations. In the absence of autonomous termination, the algorithm is halted after max iterations. Okay. No skip counter variant count is incremented by 1 if there's no change in its opinion. That's set to 0 if there's a change in the opinion. Otherwise, the counter reaches a certain threshold 1. Counter greater than 1 is the node considered state as final. That, my friends, is just another way of saying current successes or success counts or whatever. What's the term that Dan uses? I do want to apologize about the omniscient attacker. I didn't realize they were going off some weird ideal that was kind of theoretical and stuff. It makes sense now that I think about it. I do want to apologize And Alexander, if you're watching this, like that was probably a little presumptuous on my part. It's consecutive successes. That's the right word. This is basically a consecutive successes thing right here. Like, they're going through multiple rounds. As incremented by 1, there's no change in the opinion that's set to 0. There is a change in the opinion. Once the counter reaches a certain threshold. Ah, that's not a 1, that's an L. Ooh. Ooh. I was like, why is the threshold 1? The threshold's L. I hate that. I don't know. Like, I am not a consensus expert, but to me, this is sounding an awful lot like Snowball. Like, an awful lot like Snowball. Moonboy9001, I hope we have so many subnets you stop caring about VMs. It becomes a matter of flavor. Like, I like vanilla today. I'm going to get a vanilla VM. I feel like having a chocolate VM today. I want a strawberry VM today. Oh, this subnet has the Neapolitan. It's got vanilla, strawberry, and chocolate. We should care so little about VMs in the long run. Like, that's the ideal. You should care. Like, literally, it should just be, like, a preference thing. Like, literally, you should just be like, I prefer this environment, so I get to use this environment. Nobody's locked into it. That's the idea that's what I want to see. I want to see it so that nobody has to care that much. Right now, it's like solidity or bust, right? But if you want to do DAML, you should be able to do DAML on your own subnet. It shouldn't be a problem. Like, the protocol shouldn't care what your VM is. That's an ideal protocol. Avalanche shouldn't care. Obviously, there's work to be done, but like a long-term like strategy, like you don't want to care about your protocol. So, like, I mean, you don't want to care about your VM. Like, you want the protocol to like, oh yeah, I built a TypeScript VM. Like, how many like they spent so much effort making Solidity so that it looked like JavaScript and it looks nothing like JavaScript. Like, it's JavaScript based. Like, it looks nothing like JavaScript, right? What the hell was the point of that? That was like the design motivation from day one. It looks nothing like it. So why not? The VMs should just run code. If you want to do, ideally, to be honest with you, my ideal scenario is that a lot of VMs won't even have smart contracts on them, and if they do, it's something that's non-Turing complete, because 99.9% of everything that you do in a smart contract, or any smart contract that's ever been written, I'm pulling a number out my ass, but it's a solid number, trust me. 99.9 smart contracts. It means only 1 out of 1,000 actually needs Turing completeness. And that Turing complete behavior is 99.9% time what is screwing people in smart contracts. In terms of gas cost, in terms of security, like the fact that you can't audit your contracts for cheap is because they're Turing complete, which means that it becomes difficult to do, like, you have to do branch prediction on everything. It's just ludicrous. You can formally verify non-Turing complete smart contracts. It's very difficult to verify a Turing complete smart contract. Now, formal verification might not be all that it's cut out to be, but you know, it's still like you can do it trivially, almost, like, not really, but like you can do it much better on a non-Turing complete smart contract. You could do formal verification and basically say this always works like this. This always adheres to this rule set, which is, you know, this will never violate that. You know, that kind of thing. This will never go over. This will never overflow. For instance, this is a great formal verification rule, right? You can put a formal verification rule on a particular variable. It says this will never overflow, and then you go through your smart contract. You find a place where it actually overflows. You go, oh crap, my contract overflows this variable. Now, that's a great rule to put on a scalar, right? Any scalar. So yeah, I mean, like, those are the kind of things that you can't really do very well in a Turing complete system, because you have just an innumerable number of possible branches to predict typically, and so the tool sets don't work for it very well. They can try. They do a lot of things like fuzzing and stuff, but like you do much better with like non-Turing complete languages. Like, Anyway, so back to this. Is there some kind of security deterministic advantage that come with non-solidity languages? I mean, it really depends on the language, you know? Like, it really does. Like, there's preferences out there. Like, some people feel like they can design more securely in Haskell. That's fair, I get it. Like, you think you can, then you can. It really, ultimately, all it like, in a language like Solidity and on the EVM, it compiles down to bytecode. I mean, technically, everything compiles to bytecode in some fashion. But, like, in Solidity, it has their own ops, their own costs associated with those ops, and, you know, that's one way to do things. And, you know, you can use any language for that. Viper is a Python-based language which compiles down to the EVM bytecode. It's not Solidity. There's also something called LLL, I believe, which is a functional-based language which compiles down to Solidity, right? So, is it LLL? Whatever. So it doesn't matter. The underlying way that the machine handles the code itself is the problem. The underlying way that the virtual machine works with the code is a problem. And if you give it an operations set that's, you know, like Solidity, where there's whatever. Yeah, it doesn't matter. The language shouldn't matter. It's literally how the VM executes on the language. How many times have like look at Node.js, for instance, like that needs patches. They patch that thing all the time. Oh, we found a vulnerability, random vulnerability on Node.js, right? Node.js is kind of a VM when you really think about it. Like, it's not a blockchain VM, but it's a type of like virtual environment which runs a piece of code and executes blah blah blah, and should be the same for every input, should be the same for every output, same output for every, you know, if you don't change your inputs, blah blah blah. Anyway, invariant with the inputs and outputs, I guess. Like, it shouldn't matter. Like, the language ultimately shouldn't matter. It's just a language. Languages, C++ compiles to x86 architecture. Okay. Well, so does Fortran, right? So does COBOL. So does Rust. So does Golang. So does D. So does C. Regular vanilla C. They all compile to the same architecture set. The language ultimately isn't the source of the problem. I mean, the languages put protections in there to stop the developer from screwing up and doing undesired results. But, you know, a lot of these weird behaviors you see in the smart contracts actually are, like, I don't know, unintended opcode execution, essentially. I don't know. It shouldn't matter. I mean, there's a layer of complexity that's get added when there's not one universal language for smart contracts, that's for sure. Like, everybody's got to do their own testing. Do you know if this VM's safe or not? But you don't know that for anything. The only problem is billions of dollars are running through this network, so you want something that's hardened. So is there some kind of security or deterministic advantage that comes with non-Solidity languages? It's not about being Solidity versus non-Solidity. It's about the VM at the base layer, and then it's about the language layer, how it protects the developer from themselves. And, you know, some of those things can have additional advantages, like Pact is a smart contract language that is not Turing complete and has formal verification baked in. So you can do things like check buffer overflow on variables right out the gate, or SHA-256 like hash collision weirdness. Like, not sure why you'd ever need that. It could be that you have two inputs of the same by accident into your function, and you'd want to prevent that from ever happening. So you do a formal verification to make sure that never happens, right? I guess maybe that sounds dumb in my brain now that I say it. You know, there's a lot of things out there. So anyway, language ain't the issue. It's the whole ecosystem that's the issue. And people can design better ecosystems. They should be free to. Right now, everybody's stuck. Everybody's locked in. You know what I mean? Lock-in is a big problem in most tech spaces. So look at Apple, man. Apple's a prime example of lock-in. Once you start using their stuff, it is very hard to get off. You know? Lock-in. Well, VMworld kind of frees us from lock-ins. You know, having multiple VMs and all that kind of stuff, you don't have to force your users to develop on whatever. Anywho, back to this. We consider the worst case scenario, average series of the nodes exchange information freely between themselves and agree on common strategy. So all business nodes are controlled by a single adversary. There's a cautious adversary, semi-cautious adversary. All right, so any adversary node must maintain the same opinion, the same round. Okay, fair. Semi-cautious adversarial nodes will not give contradictory responses. Okay, so I can... Got it. Berserk adversary. Yeah, okay. Proven that when the protocol parameters are suitably chosen, the protocol finalizes in a consensus in a finite state of time with high probability. But what are they actually proposing here? Like, so far, it really... I don't see where this random beacon thing comes in yet. Like, they posted it here. It said it makes use of a sequence of random numbers which are either provided by a trusted source or generated by nodes themselves as some decentralized random number generator by leveraging cryptographic primitives such as verified secret sharing, threshold signatures, cryptofactors, or blah, 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 VDFs. Specifically, a reasonable approach could be use a variable to... Okay, what is your approach? It's important to observe that... What does that do for you? They're just trying to force majority rule, I guess. And they're afraid that somebody's going to have... In the unlikely case, somebody has that much vision into the system. So I guess, all right, so let's see. Maybe you own 30% of the network, 20% of the network, and you want to mess with the network. How would you do that? In Avalanche, you would minimum stake across thousands of nodes, which of course everybody would know you're doing, probably in reality. And then you would just start sussing out what the node's state is based off their previous preference, and then start screwing with that. But again, remember, you're sampled by stake amount. So you get sampled literally the same amount if you have 2,000, 102,000 nodes, right? Or if you have 200,000 stake node, right? It would be the same. You would have it would be a wash. The only thing is you would get less of a better staking percent reward. So you'd actually be hurting yourself because you would get your staking reward goes up. Well, does it? No, I don't think so. With the amount staked, I don't think it does. I think we talked about that. I don't know if we actually implemented that. I don't think we did. Anyway, all right. So I'm kind of lost at this point. I'm not going to lie. I'm not sure how the random beacon actually does anything for them or where it's injected. Okay, so they're setting their quorum size, which in our world would be alpha. Means you need at least 21 nodes to reach a quorum. I guess they're not saying that. Quorum amount would be, yeah, okay. So that'd be K, I guess. K would be like 20 in ours, and then I think the default parameter right now is 14 alpha, which means that you need, 14 over K, or 14 over 20, which is, actually should be 16, I think. It should be 60%. Quorum size, is that right? That's 0.8. Okay, cool. 14 over K. That'd be 70%. Ooh, brain. Was the initial threshold of 2/3. Compares the effects of IVS and MPS on histogram nodes. On the other hand, Berserk... Oh, jeez, dude. Like, guys, I don't even know what the hell they're talking about at this point. They're injecting so much mechanism design into this paper, right? I guess maybe I'm missing... The initial average opinion P0 equals the initial threshold. Yeah, I'm already lost, so I don't know if I want to go through this anymore. FPC in its vanilla version is described in blah is not robust against Sybil attacks as an adversary could deploy an excessively large number of nodes, thus inflating the value Q. In section 2.3, Sybil protection is implemented by mana. Like to cast a spell? We changed FPC such that a node is queried proportional to its mana. Yeah, like to cast a spell. Okay. Stake, I guess, right? It's kind of like a karma system, maybe? There's multiple, or you have a, like, maybe you've got like a gauge. You're only allowed to vote but so much, but then like stamina and Dark Souls, the more you swing, the more you deplete. And it's got to recharge, maybe? As multiple clears still increase message complexity, this allows creating a bigger quorum using the same communication overhead. In turn, a larger number of samples increases the safety of the protocol. How do people know what other people's manas are? I guess you'd have to spend your mana. How do you know you've earned or minted new mana? So this must just be stake. Like it might just be another word for stake. Or karma, I don't know. Yeah, I don't know, man. I think I'm burnt out on this already. It just keeps going. I think they're freaking depending on that. Okay, here we go. Something I could read. That's a heartbeat function. Okay. Each neighbor J to do send opinion to neighbor. For each J to send opinion next to neighbor J. Whoa. Why can't they just okay, so here. All right. Opinions collide. First nodes update opinion. Pictures. Pictures are pretty, right? It's complete. Nodes update their opinions. Compete. Single opinion survives. Okay, so this looks an awful lot like what we're doing. Each node knows the opinion of its neighbors. That's interesting. As well as the opinion of all the neighbors. Well, what's this neighbor stuff then? How are they doing neighbor clustering with this stuff? Like, how are they... Where would I see that? I guess that would be under auto-peering, huh? Global node identity, still protection, the mana... Oh, there's the mana system. Principle of mana system is one that should have mana where the more one contributes to the network. Contribution is naturally associated with how much stake one holds. Yep, okay. But although having tokens helps the network, one should... Dude, I don't even know what to say, man. Like, thank you, node text editor. Like, I don't want to read this anymore. Like, I came in here with, like, the idea of just, like, railing on these guys, but the only thing I can come up with is, like... This is obfuscated to a point of... Yeah... Alright, so the principle of mana is that once you get or have more mana, the more one contributes to the network. So, by contributing to the network, you earn mana. I assume that you have a base level of mana. Contribution is naturally associated with how much one stakes hold, but also having tokens helps the network, so one should not be able to mine unrestricted amounts of mana by simply holding some quantity of tokens for a large amount of time, or by frequently sending tokens around. What? So... Oh. Yeah... This is like what they do. Yeah, okay. This is where you have to constantly flood the network thing. But I feel like they kind of must have dialed that back and just tried to make it as proof of stake-like as possible. Alright, when funds are spent from an address, the pending mana is a... Why would people want to force people to send stuff? Yo, dude, why am I... They're literally saying here, am I misreading this? To be able to have mana... you must send things on the network. You must be a user of the network. So I have to, if I'm a node, to earn mana, I must spend transactions on the network, okay? I'm constantly sending things, right? Proportional to the stake I've put into the network, I generate pending mana. When funds are spent from an address, the pending mana has been generated by this address. Okay? It's converted to mana and pledged to a node. I pledge my mana to a node. And it decays over time? How? Okay, so there's some decay rate for the mana. That we're using this variable. Okay. Dudes. For real. Mana cannot be gamed. Alright, so... Alright, from a high level, I'm just going to assume that this is sufficient for me to know. Pending mana. So pending mana is when you have stake, you get pending amount of mana proportional to that stake. When you actually start spending things on an address, it can be pledged. You could pledge the mana from that spend to a node, and then that mana decays on that node if that node is not like using it. Okay, fine. So we go down to the consensus protocol. No, it's a token-ish. It's a decay token. So it's like a meme coin, man. You send it, and it allows you to have voting power, or I don't think I think it's voting power, not proposal power on the network. Dude, what the fuck? I shouldn't say that out loud. I shouldn't curse. Where am I? I think it was 6 point something I need to look at. Okay. Mana. Where am I? Ah. Wait. I saw a thing. Mana FCC in its vanilla version described in 6 is not robust against Sybil attacks since an adversary could deploy. So, where's 68? Okay, so the original thing. So, section 3.2, Sybil protection is implemented by Mana. Okay. We change the FPC such a node is queried proportional as Mana and do not query a node multiple times as multiple queries don't increase the message complexity. This, wow, wait. A node is queried proportional to its mana, and do not query a node multiple times. I should be able to query a node multiple times, but they're not. They're not doing with replacement querying. Got it. Okay. So as a node, I should not be able to do multiple times, but you and me, as two independent nodes, could query the same node multiple times, or for the same thing. Okay, that's fine. So multiple queries don't include message complexity. Ooh, a freaking blog post. Let's see. Yeah, I think I get it. Let's see. One of the topics I had to is frequency of questions about mana. Is this an important topic? So, okay. The goal of the post covers basics requirement of every DLT to have both Sybil protection, and congestion control. Explain the okay. High level our view of the implementation of mana in IOTA to the strong thought. Okay, every DLT needs a few components in the context of the discussion. Sybil protection produces attacks. Yes, I know what that is. Mana is perhaps best thought as a tool used in various roles in the network, but is also remained separate from the IOTA token. When a value is transferred, blah blah blah, pledged to a specific node ID. Yep, got that. Okay, this quantity is related to the amount of IOTA moved into the transaction. Okay, the mana pledged to each node ID is stored as extension ledger. The only way to gain mana is to convince some token holder to pledge it to you. Okay. Fair. Oh. Yeah, stream was bad. Am I blurry, guys? How's my visuals? Am I blurry? Additionally, mana functions as Sybil control mechanism in the congestion control, blah, blah, blah. Pledging the process performed twice. Okay, cool. This is done in order to ensure maximal freedom and security in the network. Why? What does that mean? What do you mean? Why is it maximal? Because incentives for security and access potentially odds, the separation ensures that users will always be able to enact away best secures network while preserving their freedom to allocate access according to their economic conditions. Token holder is also able to delegate their access without giving. Yeah, man, I don't know. Oof. In this section, we list several important aspects of mana. We cover the mana calculation, how mana is. How do people get through this? That's what I don't get. Like, how are people just reading this? Like, this is exhausting. And additionally, civil protection, or IOTA implementation introduces 2 ways to calculate mana. I don't care. The second way to manage to calculate mana is augmentation, blah, 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 blah. Okay, however you calculate it, I don't care. The team is studying which choice makes these twos better by... Okay, go Shimmer. Weight of both the consensus mana is given a node. Total active mana. The mana is held by nodes active in the network. For example, if a node has... So basically, as a node operator on the network, I got to convince you guys to fund me to be a node operator. And that's what mana is. I guess. Now, does that mean that I can be queried? I think it means I queried based off the amount of mana. I'm more likely to be queried. Which means I guess I'm more likely to be incentivized. Like mana converts to IOTA or something like that. Yeah, man. Alright, well... I'm done. I am done reading about mana. There's no way I'm going to keep reading about mana. So, Berserk Detection Protocol. Yeah. It sounds like it's kind of like that, but it's like you have to really like tell people like to send you the mana. I don't see any reason why I would ever like pledge my mana to you or anybody else. Do I just pick a random node ID? So there's no proof of work in IOTA. Okay, that's nice to know. So for you, for purpose of honest users, I apologize. The protocol implements something called adaptive proof of work as spam prevention. Honest nodes creating transactions will have to do very small proof of work to create a message. However, malicious node, that sounds reasonable actually. Yeah, that makes kind of sense. Alright, anyway, done with that. Look, I see Snowball in here, but it's hidden pretty well. So they're doing multiple rounds, right? Yeah. Yeah. For example, if a node is in the mth round on voting on a particular conflict, it's a tricky. So yeah, they're doing Snowball. That's what they're doing. Like, this is Snowball. I'm pretty convinced at this point that they're just hiding the fact that they're doing Snowball. Like, this is legit Snowball. So this is stuff I guess they're going over the Wolfram stuff with. Like, each node knows the opinion of his neighbors and all that. I don't know, man. Guys, look, I can't keep going. Oh, wait, whoa. Cellular consensus. Okay, here we go. Send initial opinion to its neighbors. So I guess neighbors is just a random sampling of 10 nodes on the n nodes on the net, k nodes on the network. So you select k nodes, and then you do a random sample of k nodes on the network. And then for each node, you send an initial opinion. Oh, YouTube? Great. I don't really do YouTube. I'm on Twitch. Tell them to come over here. What? Let me see if I can pull it up. I got a multi-stream thing. I just don't know if the chat... It doesn't look like it's there. Hold on. I gotta go on another... YouTube is just so I could back up the videos forever. So like, there's actual clips on YouTube, but like the YouTube streaming stuff is not. I don't use YouTube for that. It doesn't look like it's there. Hold on. There we go. Dom, this is a mess, bro. I don't know if I even want to bother. Yeah, come on Twitch. Yeah, it's it's a creative whatever, Creative Commons playlist I put up. There we go. DM me. Actually, I see what you're saying. This is gonna be a mess. So, you know, I'm talking to the guys in I'm talking to Dom from IOTA on the YouTube thing. I'm gonna close YouTube now. Yeah, it is hilarious, by the way. By the way, guys, you IOTA guys, just so you know, it is absolutely hilarious how hard this is to parse. You think this is a good thing? Like, you legitimately think this is a good thing? Because it's a fucking hot mess. That's why. It's like, piss is Sammy. PC Sami, whatever. This is a mess, guys. Legitimately, though. Like, this stuff is so full of custom jargon and nonsense. Like, what are you doing? Like, this is a fucking mess. You should be ashamed. This is so bad. Legitimately. Please, come on. Please. Please, come on. I'm ready for this. This is so ridiculous, guys. DM me on Twitter. I will put your developer. I can add you to the stream. I can only add one person right now, just because that's the number of windows I have set up. I actually got to find a different template if I want to add more people. But, like, look. If you want to come on, we can talk about this right now. This is a fucking mess. All right. Like, this is why this is like why mechanism design protocols are just annoying. Like, this is spaghetti as crap, right? Like, what are you talking about? You got cellular consensus, you got your FPC consensus, you got your mana. Oh, we use mana because we're cool. Like, what the hell are you talking about? Please come on. Please. I would love to be like, this is what clean looks like and this is what dirty looks like. Huh. And yeah, I messed some things up earlier. Definitely. No question. I'm human. It happens. I also corrected myself. But like, I don't even know where to begin with this. Like, why am I going to spend my energy reading this? You haven't been able to build anything that works yet. Okay? Like, nothing. Nothing the IOTA has done at this point has worked to date. Now, the one thing that looks like it's going to work is copying Snowball. And I'm seeing a lot of similarities between here and Snowball. So I need you to show me how it's not that. Because the bare minimum you need to do, please come on, please. The bare minimum you need to do to satisfy Snowball consensus is random sampling of k nodes from the network, okay? Querying those nodes, updating your probability, updating your confidence in your preference. You query their preference, you update your confidence in your preference with consecutive successes, like, you know, over a threshold of people responded X, so therefore I'm updating my threshold as well. Okay? And you do this for a certain number of rounds until you've reached a threshold of rounds where you're just like, yeah, a threshold of consecutive rounds where you're just like, yeah, this looks correct. Right? You just keep doing that. Repeat until you come to a number of consecutive rounds where you actually say, hey, yeah, I can lock this in now, right? Are you doing that? It looks like you probably are, but it's very, very difficult to like make sure of that. Just some of this stuff looks very, very, very similar to that. What I don't get is what advantage you would ever get from adding a random beacon to this. Because that is sufficient, as is proven, that process is sufficient to come to consensus on the network. You will come to a decision. The network will come to a decision, okay? You will choose a preferred transaction. When given two conflicting when given a virtuous transaction, the network will just accept it, right? Like they'll do the process, but it'll come to consensus very quickly, right? But when you have conflicting transactions, it's got to pick one of them. So why, like, the whole network just has to choose one. That's all it has to do. Choose, this is the preferred conflicting transaction, conflicting vertice, let's just say. Okay? This is me, not a PhD or anything, lecturing you right now. Okay? That's all it does. And through doing that, we have shown that you can come to consensus across the whole network, right? It doesn't seem like you're even debating that. You're trying to put some optimization in for what I can only tell is either one or two things. You think it'll terminate faster if you do it this way, which I'm not sure it does. Everything that I've been reading says that you guys have not, I don't know. Maybe you've not been implementing it properly to begin with. The other thing is, like, I'm not sure what the adversary situation you predict will happen, how that will actually like slow down the network to the degree that it requires something like this. How it will prevent termination to the degree that you think it will, because it has shown that it really doesn't, right? It really doesn't. You come to consensus pretty quickly in Avalanche, like really quickly, even with conflicting transactions. So what are you doing? I'm ready to have you on here. Absolutely. I'm still waiting for that DM. At Colin Couchet, Twitter, right now. Come on. What are you doing? What is this? What am I missing? It's really possible I'm missing something, because this is really hard to parse. Do you think it's easy? Do you guys read this and go, oh yeah, I got that the first time? Like, is that what you think? This is like when I was reading the polka dot paper. It's the same feeling of just like, this is just Rube Goldberg mechanism design on top of mechanism design, you know? This reads like an academic paper. We propose this. This is the process. Here's the pseudocode. Do this, and you will be able to do that. Here's the 3 steps of the process. You know? Slush, snowflake, snowball. And like they're only just adding on to each other with each step because you're building up to an ultimate like thesis, right? You're building up to an ultimate thing. This is like one big mess. You've got, well, you're talking about your previous work that didn't work. Thank you for that. You got your node accountability system, your civil protection principles, your mana system, auto peering and network reorganization and results and again, civil protection again. Rate control, like these are just like, oh my god. You know, if you have gems or nuggets in here that are really good, really unique, it's hard to spot them because you're not putting them front and center, I'll tell you that. How's that? How's that for some feedback? You know? You're not putting them front and center. If there's some really cool stuff in here, I wouldn't know. I wouldn't know. And, yeah, the easy like, FUD answer is Colin Couchet's an idiot. Colin Couchet admits he's an idiot. Colin Couchet is not a consensus protocol expert, but I'm doubting if you guys are. This is a mess, and this is not. I don't know where they're going. I don't know. And this is purely my opinion, man. Like, I'm just going based off of what I'm reading here, okay? If somebody wants to disagree with me, I am open ears, okay? I'm freaking open ears. Please tell me I'm dumb. I get better by being proven wrong. I am not going to be insulted. I'm not going to be defensive. I will eat crow live on stream about anything because I am just all about finding out the right thing. And I've done it so many times in my career, especially in the crypto space, where it's just like, oh yeah, I'm an idiot. I do that all the time. It's fine. But you gotta admit to me, this is way harder to grok than like you're proposing here is like you have to prove the mana system. You have to prove it. Okay, this is one white paper. Mana like if mana works and it does the thing that you say, that's one white paper. But I don't see proof. I don't see any of that. Now maybe they're out there somewhere. Maybe let me see. Do you have like references for the mana system, like in our mana white paper? Let's look. And I'm not an academic, guys. You know, I'm not. I didn't even know that Cornell was a good school. I'm a dummy. I'm fine being a dummy. But I have to say that there is a stark difference between the stuff that works and how and how people present it, and the stuff that doesn't work and how people present it. Right? And I want you to ask yourself, what category do I think you're in? Please come on. Please. Please. Pretty please. Am I missing a... Like, I know I'm hard on you, but like, I get it. I know where you're coming from too. Like, I get it. You did all this work. You want to make something of it. You built a community. You want it to do something and go places. I get it. I get it. I totally get it. And you don't need some jackass with a Vans hat on your Twitch stream talking crap all day. You don't. I get it. That's not a good feeling. And it would piss me off too if I really believed in my stuff. I don't know if you really do or not. I don't know. I don't know if they're coming or not. I don't know. I'm happy to learn more. I'm always happy to learn more. If you have some really good insights, if this mana thing, for instance, is like, wow, why didn't I think of that before? I'm totally into it, right? But like, it's jumbled up with the FPC. It's jumbled up with several mentioning of like multiple types of civil protection, okay? Like, you have so many topics intermingled in one white paper. You got VDFs in here. That's a big topic, guys. You know? Fast probabilistic consensus protocol. It's just confusing, and I don't think it's my fault. Yeah, okay, what's this? Is this a new paper about Sergey? Okay, cool, perfect. Or what's his name? Alex Skidnoff? Sorry. No, Sergey Popov. There we go. People have told me recently it claims that IOTA cloned Avalanche, which are being expressed since the release of Shimmer. And initially I thought, it must be those Twitter experts, not worth even a second of attention. And I went back to work. However, my great sadness is I have learned that among these people, there are some which I enjoyed a great blah, blah, blah. I get it. And you're defending your work. I understand that too. I understand when people want to defend their work. I just have to wonder how genuine it is. I really just be about others being president, blah, blah, blah. Okay, let's see. I'm literally hunched right now. Like, I came in this with this attitude of, I'll just read their paper. It'll be easy. I'll just go through it. I'll make it work. Happily reinventing the wheel. See above. Is this the thing they reinvented? Where is it? Interacting particle systems includes a so-called voter model. This model, in fact, is a classical model to be described with the following. There's a graph. Each site has an opinion, 0, 1. At random moments, each site consults some neighbors, adopts either their opinion. At a very small important in most cases, voter models. That's not Avalanche. Are there repeated rounds here? Like, what is this? All right. And it's also talking about neighbors. Like, there's no concept of a neighbor. It's a random sampling from the entire network. So that's not correct right off the bat. Unless I'm like missing something, that's not equivalent to what's above. Unless, let me read this. What's this? This might be. Let's see. Let's just start here. If K is less than N, blah, 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 blah. Of course, K has to be less than N. A consensus protocol. I guess it could be equal to N, huh? There's an update rule that is execute each node. The goal is to reach a state in which all nodes support the same color. Yep. Special case for nodes pairwise leader. DC color is a leader election. Important improvement of distributed computing. Quality of each interest in the consensus time. Blah, 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 blah. We assume severely restricted and simple communicate. Okay. There's a discrete round. Nodes independently pull information from some typically constant number of randomly sampled nodes. Okay. We are interested in protocols with low memory and low message size. We distinguish between consensus dynamics and consensus protocols. Consensus dynamics are a subset of consensus protocols, which blah, blah, blah. Okay, cool. Consensus protocols on the other side, more complex. You're trading off additional memory, larger message size against faster consensus. Okay, cool. Consensus dynamics. We start off by overviewing blah, blah, blah. The voter process known as polling uses the most naive update rule. In every round with a probability of 1/2, each node samples one neighbor independently and uniformly at random. Okay, neighbors, interesting, but I guess they're all neighbors of each other. I guess if you pull from the... Doesn't matter as long... I'll ignore that for now. Otherwise, the node keeps its current color. Also, we consider a non-lazy version of the model where every node samples one neighbor in every round. Two choices, three choice majority process. Their rules consecutively every node default. Sample two neighboring nodes independently and uniformly at random. Okay. If the samples have the same color, adopt it. Otherwise, ignore them and keep the current color. Three majority. Sample three neighboring nodes independently and uniformly at random. Color supported by at least two samples. Adopt it. Okay. Start by considering the voter model on general undirected graphs. Results voter. The voter is in the dual or so-called coalescing random walk model, which is a fundamental stochastic process on connected and undirected graphs. At the beginning of the process, there is one particle on each node in the graph. At discrete time steps, every particle performs independently one step of a random walk. Whenever the two or more particles arrive at the same node in the same step, they merge into a single particle and continue on a single random walk. We are interested in the expected first time step where only one particle remains, to which we could refer to as coalescence time. Voter process viewed backwards is exactly the same as coalescence process start with the random walk on the node. Thus, coalescence time tcol and consensus time tv have the same distribution. In other words, they're bound. So this is a okay. This is not exactly the same, but it is very damn close. So it is not a generalized avalanche implementation, but it is on the way for sure. I think so, at least. I think he's correct in that. I think it is close. That is close. It is very restricted, but it's close. Instead, we like our algorithm to setting asynchronous models. The results. We consider three protocols: rapid plurality, consensus, as well as two protocols as have a balance and shuffle. This might get interesting. Sorry. What's up, guys? I forgot you were there. Hold on. Avalanche does not vote. Nope. What? Avalanche is a voting protocol. Hold on. Key to our fast. Avalanche is a voting protocol. I don't know what he means by Avalanche does not vote. We are a voting protocol. First subphase is one of two choices, and every node that changes color propagates to its second subphase is essentially pull rumors spreading with multiple rumors. While this process is not difficult to analyze in the synchronous model, it becomes very challenging with the asynchronous. Okay. The reason for the rising difficulties is that the aforementioned protocol relies heavily on simultaneous execution of the phases, which is no longer the case in the asynchronous realm. Nevertheless, we were able to adapt the aforementioned protocol to there. It's close. Yep, that's where it's... Yep. Plurality consensus time. Interesting. This is the best possible consensus time. So some nodes will not even have ticked off after omega log n, and have therefore not queried a single to make them work with different weakened notion of synchronicity. At any time, we only require fraction nodes to be almost synchronous. This relaxes full synchronicity in three ways for blah, 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 partially asynchronous. Well, partially synchronous, I guess. Finally, we require to hold only a hybrid. Above notion does not require nodes to synchronize actively per se, since the number of ticks. This is interesting. Is there knowledge, no efforts? I think I need to ping somebody else on this one. So I'm going to delay my decision on this one. This looks very close. I mean, it's not actually Avalanche, don't get me wrong. Like, it's like a small, like, subset, kind of, like a build-up to it, almost. Using a restricted number of, like you need, like, a 3 majority. It was, like, there's no generalization, so we have that whole concept of alpha, which they just set alpha equals to... they just set, like, basically 3 majority is all you need. It's interesting. But it's not the same. For sure. They got a lot of... It's like a very restricted... But it's kind of cool. I'm geeking out on this a little, but I want to ping Kevin probably about this, because I bet he's read it. And get a better idea what's going on. This... Alright, this is a bit much for a stream. It's going to get very boring here in a second. So I'm going to shelf this. I'm going to shelf this. But that's interesting. That is interesting. Alright, so let's go to what Sergey says. A year ago I learned that Avalanche paper, quickly skimmed through it. My pressure followed. 2 authors happily reinventing the wheel. I don't know if that's the case. I don't think that's the case here. Like, this is not the same wheel. Like, does that make sense? This is, just because it's round doesn't make it a wheel. Where is this paper? Oh, here it is. For some reason, they like using the words that had meanings. Yeah, I concur with this gripe. Metastability is a very frustrating term. Never going to call it a tool. Call it metastable, a model named Slush, which is a random walk on a concave potential, which therefore doesn't have any potential wells. Right, and they apparently think that metastability, which indeed manifests itself in the presence of Byzantine actors, is something cool, while in reality it's completely opposite. In this context, if the system is in a metastable state, it means that it's stuck in a away from consensus regime for a very long time, which is obviously because it's probabilistic consensus. That's what it means. Like, and not only that, but like it does actually converge onto a state. Like, so, like, it's not away from consensus. Like, every node in the network will eventually come to consensus, which is why I also don't like the term metastable, because it's not like you're teetering on the edge of a pinhead. You're literally going to come to an exact consensus thing. I'm not sure what the metastability is to this day. I've asked actually working at Abba Labs. So I agree. If you want to have gripes about the word metastability, that is a valid gripe. But I don't think... I mean, maybe that I think it's a valid gripe. I might be wrong. So, but we share the same problem there. So we share the same, you know... I am not more handsome than Goon. I'm not saying it to kiss butt. I am an ugly boy. So I'm fine with that. The academic level of that paper is low, besides not mentioning the previous relevant work. When the authors try to write any serious math, the result is, to put it gently, unconvincing. Okay. Cool story, bro. Most importantly, their system was very likely unsafe. This is an adversary is able to maintain the system in an undecided metastate for a very long time. Prove it. Like, that's the thing, is like, it's out there now. Like, it's live. I'm perfectly fine. If you show that this doesn't work, that is equally as interesting to me as this working. Because if it doesn't work, either we got a way to fix it, which is good, or we go, oh crap, Avalanche doesn't work. Let's pack our bags and go, right? Like, go build a test network. Like, he got the code, man. And the worst part is he wrote this, but like, it's basically what you're doing, right? So let's see. All right, now back to IOTA. You might know from the differentiate. We're trying to embed everything pivoted to the tip selection algorithm. This gave rise to an interesting theoretical project. Although never completely satisfied with it, probably would have worked without coup, but I don't know what that is. Probably Coordicide, I guess. No, I don't know. Remember research card, probably blah, blah, blah. Voter type models. Okay, so hold on. This statement is very sus. So, all right. So, like, there are classical voting protocols out there, and they are resilient to Byzantine nodes, the Byzantine BFT, classical consensus protocols out there. And they are resilient to Byzantine nodes up to a certain threshold. For an asynchronous, partially asynchronous model, you have a limit of 33%. Is like a hardest limit you could get on asynchronous. Like, you're just like 33%, and you're like, you can't get any better than that. Anything above that, you get a 34% attack. It's like a 51% attack in Bitcoin. Same S, different day, right? All assumptions are off after 33% Byzantine nodes. So if you got 100 nodes, you got 34 of them are Byzantine, or you got, let's just say 100% of each node is one voting power in this scenario, then you cannot go above 33% in an asynchronous network without the assumptions being failed, and then all bets are actually off, like completely off. Boom. You are not guaranteed to have any sort of like smooth degradation on that either, like we do with Avalanche. Like, you literally, all bets are off. Avalanche is a voter model, though, just to be clear. But it's probabilistic. All right, wait, where is I going with that? Oh, yeah, it's 50. Also, by the way, in synchronous models, you can have synchronous voting protocols that are 50%, resilient to 50%. So you should know that as well. Like, that 33% is unique to asynchronous. In a synchronous world, you can get to 50%, and then after that, you're boned. Okay. But that's the assumptions. What do you mean, like, they're not typically resilient to a significant number of Byzantine nodes? Bitcoin is resilient to 50% hash power, right? That's the same thing, right? You get over 50% hash power, your assumptions are violated, you got a 51% attack ability, right? Okay. The problem is that there's not enough nodes in the network on these voter protocols that you're looking at, probably. Like, the number of nodes in classical consensus are pretty much the speed that you come to consensus, and the number of transactions you can get through the network drops significantly after about 100 nodes, right? After that, you're going to see significant performance drop at the scale of n squared relative to the number of nodes. So n being the number of nodes, n squared is this drop off, right? You know, in a practical network past 100 nodes, you're in a Byzantine environment especially, you're going to see you're going to see the things kind of like taper off and start to suck, right? So, like, but the Byzantine percentage of Byzantine nodes is not really changing in these classical protocols. Meanwhile, I don't know what he means by the SIPA is not typically resilient to a significant number of Byzantine nodes. Like, what does he mean by that? So, they can usually admit to no more than the square root of n adversarial nodes. What? No. Unless I don't, like, what are you talking about? No, it's 33%. N is the total number of nodes. It's 33% for, like, most classical protocols, and for Avalanche, it's 60% for safety. And that's only in our configuration. It could get up to 80%. It could be parameterized that high. No, that's just patently false. Unless I'm completely misreading what he's saying here. This statement, square root of n adversarial nodes, where n is, maybe, unless I don't know something, which is also possible, I can only go off of what I've been taught, right? Like, at the end of the day, that's where everybody deals with, right? They only could go off of what they've been taught. Everything that I've been taught so far has been taught by world-renowned experts in consensus protocols, but they might have left something out that I don't know. And that's always possible, right? That's always possible, but 33% is the cap for for classical protocols, voting protocols that you were talking about. And that's not the same thing as square root of n. Right? So if you have 100 nodes, you're saying to me that, what is it? 10? 10 times 10 is 100. You cannot have more than 10 Byzantine nodes in the network? That's not true. That's just not true. Right? That's false. That's not true. It's like, ask Zaki Manian, who runs Cosmos, if it's true. If you don't believe me and you don't believe the Avalanche, their protocol is a classical consensus protocol. Okay? That's why they use DPoS as their civil protection. It's a classical consensus protocol. So, ask him what his limits are. Is it 10? If he had a 100 node network, is his limit cast at 10 or is it 33? What's his limit? I guarantee you it's not square root of n. I'm pretty sure I'm right about this, guys. I'm not a consensus expert in the world-renowned sense, but I was taught by many of them. That doesn't mean I was taught everything, so there's things I don't know. Unless he's got something I don't know. This is not correct. So fun, like right there. All right, and that's like base level. That's like the first month or so I started working at Alva Labs, they taught me this stuff. And then they reiterated it like 6 times because I didn't get it immediately. Like I said, I'm not the smartest, I'm not the brightest bulb in the tree. I'm not the dumbest one. I'm not the dimmest one either. 80% of the supply is not held by Alva Labs. That's false. Is it sale? What is it? info.avox.network. Is that it? You can see our distribution here, okay? Clearly not 80%, dog. Like, look at it. It's right there. Information's there. Go get it. DYOR. The people who suck are... the people who are not doing well are always the first to tell you to DYOR, right? But like the moment they say something false, like why didn't you DYOR, dog? Why didn't you do your own research? Look, I'm trying to do my own research literally right now on air. That's why I'm open to being wrong, because I'm literally doing my own research. And I could be wrong about so many things. And I want this chat to correct me. And I want you to correct me. And I want the IOTA guys to DM me so that we can pop on the air and literally talk live. Like literally, fucking teach me, man. Yeah. Every time I'm wrong, I learn something new. Love it. Do it more. Please, show me I'm wrong. All right. Back to this article. I'm gonna go. I'm already tired with the Coordicide paper. I'm already tired with it. I really am. I'm exhausted. These guys have not produced anything in 6 years with a ton of funding. I don't know what else to say. 15 months, maybe 2 years if you count like when Steven started doing his stuff. Maybe a little longer if you start some of the pre-research. Like we built from company start to like end, like let's just say 2 years, we built an entire network, right? An entire beautiful network that works. And yeah, we have our bumps and our hiccups because it's early. I get it. I'm not trying to brag either. Like Ethereum did it in about the same time frame. Like just hunker down, put your nose to the grindstone, and produce something cool, okay? We did that, and it works. I believe it works. If you don't believe it works, show me. And while you're showing me, smash that like button and subscribe. Don't forget to ring the bell. But like, I can't go around reading and catching up with everybody who says that we're full of crap or that they're not stealing our stuff. Like, when it looks like you're stealing, and I don't mean steal, I mean like, Flare is Flare is taking the code base, or at least they were. I don't know if they still are. They were just like straight ripping off the code base. IOTA could be re-implementing Avalanche. That's, you know, reasonable. That's a reasonable thing to do. And the reasonable thing to do once you find out there's a patent on it is to back out, and say it's not actually Avalanche. I mean, right? It's a third class of consensus protocol. It's a completely new thing. Of course, people are going to want to do it themselves. Like, that makes sense. Especially if they're floundering to begin with, and they're close enough because they have a bunch of DAG stuff already due to the fact that IOTA is a failed DAG project. Or flailing. I don't know what Avalabs is going to do. I don't know what well, first off, I want to be clear about something. Avalabs is not the name on the patent. It's Cornell. Cornell is the name on the patent. Cornell filed that patent. And the people who are senior at Avalabs are also on that patent. So you know they have a license. But Cornell's the one that's going to have to protect the IP, right? You're not talking about Avalabs, you're talking about Cornell. If I recall, I mean, I'll have to pull up the patent again, I guess, just to make double sure, because I don't want to speak out of my turn. Last thing you want to do is be that guy. Oh, Lord, I'm being that guy today. Let me find it. Got them at bookmarks here. Yep. So yeah, applicant, Cornell University, Ithaca. Inventors, Kevin Seknicki, first inventor, Malfin Yin. Robert Van Rennes. That's a major name, guys. That's a major name. Like, Ted is a major name. The only one on here might not be quite as well known is Kevin, and Kevin did a lot of the heavy lifting on this, I will tell you what. Like, this is a basic algorithm. In the consensus context, it is powerful. And there's a lot of stuff that goes into what it is, how it works to the finest grain detail. I'm not sure I understand why it's called metastable. It's the only part that I'm kind of like question mark about. But otherwise, it's a good, yeah. No, a process is a process is a process. So, you know, if you add a no, so if you add a no op line, it's still the same process. You just kind of like, yeah, it's pretty easy to throw that out. Like, I wouldn't worry about it too much. Robert Van Rennes is a very academically renowned consensus protocol expert. That's all. Like, if you're outside of the academic circles, you probably don't really know him. He's low key, but he's pretty academically well renowned. Having his name on that's big. So, yeah, Google him. People in the consensus protocol space know who he is, right? Oof, that's an unfortunate name. Forgot about that. Reliable distributed computer with the ISIS toolkit. Yeah, he's a distributed computing expert and all of that stuff. Look at him on Google Scholar. This is what he writes. You know, like, this is a hardcore, like, dude. Like, he's serious business. He's on a lot of stuff. People cite him a lot. Like, he's also on the paper. Well, obviously. Like, these people are serious. What are you doing arguing? Like, They do this, I know, like, even academics get stuff wrong, but not this wrong. You double check and triple check your work when you say something like this. And you quadruple check, quintuple check, like, come on, dog. Like, you don't... I'm tired. Guys, I'm tired. I'm tired. I'm tired of this. My voice is going. It's been 2.5 hours of me just yelling into a microphone. I'm making a fool of myself with all the things I got wrong, and everybody always remember that, not the stuff I got right. Look, I'm tired. I gotta log off. So I'm gonna give you guys a second to razz me. Oh, for God's sake, what is this? Yeah. I mean, Goon is... Alright, so Emin is just informing me. Drama? Who wants a drama? Oh, I got a soundboard for this. Like, I got this. This is gonna be great. Goon's probably like, dude, why did you even start this stream, Couché? Like, you've just made my day worse. I don't blame him. Emin has just informed me through a common contact that he is not interested in any further conversation, if the information is legit. I have to say I'm not surprised. Who cares? I mean, he's literally blown you off and you're pissed. Whatever. I've given this more time than I should have. I really have. This is like me doing my personal research on air to try and understand a situation that I feel like I didn't understand. I was just taking Goon's word for it. I wanted to put in a little effort to try and understand it. And in the process, I just got tired. That's what happened. Like... Well, let's see. Why is... let's see. I don't know. Maybe he is. Maybe he's a big guy. I don't know. Maybe he's just associated with the project. Maybe he's deep in it. I don't know. I can't really put much more effort into this, man. Release something, we'll talk again. Right? How's that? Like, just let's go with that, man. Like, I know everybody's just trying to do good. Like, that's the frustrating part about this. Everybody is trying to do good. I hope. I hope everybody's trying to do good. I can't. And, like, IOTA's got their own agenda and their own things they got going on, man. I don't know. What's he doing? Is he on network security, IT security, encryption, distributed systems, some cryptography? All right. Yeah, look, I don't know. I'm not going to comment on this guy's, like, history or whatever, or even, like, anything about him. I'm not going to comment on any of that. Like, why am I going to, like, look, just like I'm not commenting on Sergey. Like, just like I'm not commenting on, what's his name? Moogie or whatever. Hans Moog. I'm just not commenting on him either. Like, I'm not going there. I'm talking about who's good at Ava Labs and who's good in Avalanche. You know what I mean? Like, who do we have? If y'all like your guys better than ours, it's cool. Go for it. Not my problem. You show us where the copying was done. I'm not going to go through your source code, dude. I got better things to do. You can show me, though. You can show me where your consensus is. Maybe I'll take a look. Offered to have you guys on air, and you said no. Or nobody gave me any contact through DM. I don't do YouTube. I'm a Twitch streamer. Alright, guys. This is about all I can take of this. So we're gonna dip out. We're gonna end this, all of this. We're just gonna end it. Thank you for showing up to the stream, all of you. I mean it. I really mean it. Like, I don't care. If I'm wrong, I'm happy to be wrong about stuff. Like I said, it's how I am. I'm fine with it. And if you guys watched anything and took anything I said as gospel, keep in mind, I have said several times, I am not a foremost world-leading expert in consensus protocols. I just worked with them. And I learned a thing or two in the process, and it made me open my eyes to what could be, what can't be, what good looks like. And I have a much better idea after working with these folks what good looks like than I did before. And I don't doubt that they made changes, and they look a lot like Avalanche to me. They look like Snowball. I'm not seeing a strong enough like declaration of this is a differentiator. I'm not. Like, it should be easy to say it's not Snowball because X. And I just do that. Like, that's all you got to say is it's not Snowball because X. And then when I look at like literally old articles, even that people are still linking me to, where they're just like literally old articles of just like, here's an article where he's just like, he's not debating it. Like, it's not really, like, it also said false things, just played on false. An idea of a randomly moving threshold, like it's not, it is straight up not debating. Where's that other article? Did I already close that? That sucks. Oh, is this it? Yeah. Like, literally, like, near guys even said literally that they are all the way up to Snowball, they're the same, and that they do some weird hokey stuff afterwards. Well, guess what? Snowball is the consensus protocol. It's the consensus protocol. It's the primitive. The Avalanche stuff is just Snowball plus DAG. That's it. You didn't, like, it's like, if you're doing Snowball, it's in the patent. So that's the problem. That's the problem you're going to be facing. I don't even know, man. Like, all right, I got to end this, guys. I got to dip out. I'm just going to cut it off here. Bye. I'm not going to just do that to you. I thought about doing it, but I'm just going to say bye first. Let's see. Drama. Couché is an idiot. I can't wait for the tweets tomorrow. Or now. I don't know. Couché is an idiot. I'm fine with that. Help me be better. Show me things that convince me. You know what I mean? It should be easy. It should be easy. Guys, it should be easy. It's not cause X. You should be able to do it in one paragraph. If you can't condense it to one paragraph, all right, 3. I'll give you 3 healthy paragraphs. If you can get to 3 healthy paragraphs, I'm not talking like essay size, ooh, we should have broken this up paragraph. 3 healthy paragraphs that show me why you're not Avalanche. I'm seeing nothing that would show that you are using Snowball. And yeah, you got all these other mechanism designs on top of it, but the primitive is there. Alright guys, I gotta go. Bye.